Good morning all. Now I am going to explain about induction machines. Okay, based upon the rotor speed, the induction machines are classified into two types. First one is induction motor, second one is induction generator. That means when rotor speed is less than ns, then the type of operation is induction motor operation. When rotor speed is greater than synchronous speed, then the type of operation induction generator action takes place. Okay, based upon the rotor speed. That means ns is nothing but synchronous speed or constant speed of the machine. Okay, ns is 120 f by p. Okay, f is supply frequency, p is number of poles. Okay, Indian standard frequency is 50 Hz. Okay, if it is a 4-pole machine, the constant speed will be 1500 rpm. If it is a 2-pole machine, the constant speed will be 3000 rpm. Okay, when the speed is less than 1500 rpm, induction motor action takes place. When the speed is greater than 1500 rpm, induction generator action takes place. Okay, next coming to the working principle of a induction motor. Okay, induction motor working principle, it is similar to the transformer working principle. See here, induction motor works on the principle of Faraday's law of electromagnetic induction and mutual inductance. Okay, now see here how the induction motor is working. Now we will see. Okay, induction motor is having stator winding, okay, better I can write here. Induction motor is having two windings, stator winding, this is rotor winding. Okay, when three-phase AC supply, that means in case of three-phase system, three windings are physically displaced by 120 degrees. Okay, this is rotor winding. Okay, now see here, when three-phase AC supply, IR, RYB is the phase sequence, IR, IY, IB. Okay, when three-phase AC supply is given to the stator winding. Okay, when three-phase AC supply is given to the stator winding, in this air gap, rotating magnetic field will be produced. This is RMF, rotating magnetic field is produced when three-phase AC supply is given to the stator field winding. Okay, it will produces a rotating magnetic field in the air gap. Okay, these are the rotor. Okay, these rotor conductors are short circuited by end rings. These rotor conductors are short circuited by end rings to facilitate the closed path for the flow of current. Okay, now see here, when three-phase AC supply is given to the stator winding, it will produces a rotating magnetic field in the air gap, right? The produced rotating magnetic field will cut the stationary rotor conductors. Okay, hence EMF will be induced. Now see here, this is the arrangement. When three-phase AC supply is given to the stator winding, okay, it will produces a rotating magnetic field in the air gap. The produced rotating magnetic field will cut the stationary rotor conductors. Hence EMF will be induced on these rotor conductors. The produced EMF will circulate the current in rotor conductors, right? Now see here, when a current carrying conductor placed under the magnetic field, it experiences a force, right? See here, the induced EMF is produces current in rotor conductors, right? Now the current carrying rotor conductors are placed in the under the influence of magnetic field will produces a force. Okay, that means it acts a force, right, according to Lorentz principle, right? Hence the rotor produces mechanical force on the rotor conductors. It will produces a torque. Okay, in this way torque is produced in case of induction machine. In this way three-phase induction motor is working. Okay, thank you all.